C, I can see there's a C drive, a D drive, an E drive. In this demonstration, we want to use the command line to navigate the file system. Now, if you grew up in a Windows world, you are undoubtedly familiar with a File Explorer. And I've launched File Explorer here. And over on the left navigation pane, if I open up this PC, I can see there's a C drive, a D drive, an E drive, and a G drive. Now, it's easy to navigate when there's a GUI. But what happens if there's no GUI? So here from the taskbar, I've pinned the command line, the command tool. And here in the command line, we want to take a look at a couple of simple commands that let me move around. And one of the things to be aware of when I'm working in the command line is that the list of commands that I've previously run are stored for this session in memory, and I can call those commands. So rather than have me do a lot of typing here, right, I've already done this, and I can scroll through the list using the arrow keys on the keyboard of all the commands that I've previously run in this session. And let's start with the dir command, right? The directory command. If I just ask for the directory, I get the directory of the current volume. And I know that I'm looking at the directory of the C drive because I see the prompt C: there. And so these are the folders that are available in the local drive. If I wanted to drill down in this list, for example, there's the program files folder. And if I wanted to change the directory to the program files folder, I could do cd change directory. And then because there's a space in the name program files, I'm going to use quotes, and I'm going to enclose the entire path in quotes. C:\whack program files, close quotes. And now I'm in the program files directory. If I wanted to go back to the root directory, I can cd whack period to bring me back up the tree to the C drive. And it's worth knowing that if I don't want to use those quotes, I can call the chdir, the change directory command, without the quotes, and it'll work even though there's a space in there. And I can see there I'm back into the program files directory. Now here, if I want to change to any of the root directories, right, any of the principal drives attached to this machine, I can just type the drive letter with a colon. So if I want to switch from C program files to the D drive, I can jump right over to D. I can jump right over to E. I can ask for a directory of E. There's my directory of E. And this is the way that we can get around in here. And of course, here I can come back to C. And you'll note that that takes me back to the working directory that I was in the last time that I was at the C prompt. I can go back up to the root. And then if I've got a full screen and I've got a lot of stuff on the screen, I can clear screen, CLS, clear screen. That'll clear the screen, but it remembers the commands that I've run. And I can still call those back here, just like this. And there you can see the whole list of commands we just run. So this is the way that we can navigate when no GUI is available to us. This is a look at navigation in the command line using change directory and the dir command. In this demonstration, we want to take a look at the command line tools that are commonly used for networking diagnostics. And one of the most common and useful tools that we have at our disposal is the ipconfig command. And if I do an ipconfig, what I get is the local IP address, whether it's static or fixed, and the subnet mask if there's a default gateway assigned. I can see I get IPv6 addresses as well. Connection-specific DNS suffixes. This is the name of my internet service provider. I see that there. And then whether or not the media is disconnected, right? And I can see that in these cases, some of these software interfaces are in fact disconnected because they're not in use. Now, this is the basic ipconfig commandlet that gives me basic addressing information. And I can see my IPv4 local addressing scheme here, as well as any self-assigned IPv6 addresses. And I know that that's a self-assigned address because it's FE80. In the same way that I know that an IPv4 is self-assigned if it's 169.254 range, right? That's what we call the APIPA addresses. Now, we can get a lot more information if we do an ipconfig all. And this really gives me all of the information. It shows me where my DNS servers are, what my DNS server addresses are. Here I see the local, for my domain, IPv6, or I'm sorry, DNS server addresses. If we look up here, again, I see the I see whether or not it's DHCP enabled. Is auto configuration enabled? Yes, it is, right? So this IP address comes from a DHCP server, and I can see that right there. I see the machine name, I see the domain that it's in, the NetBIOS node type is set to hybrid, which is less of a concern these days. We don't think about NetBIOS node types anymore the way that we used to. And if I want to get the current IP addressing information, ipconfig is going to do it for me every time. Now, the ping commandlet is used for testing connections. And I can do things with ping like 127.0.0.1, which is the loopback address, right? That's the address that all machines use to refer to themselves. And by running that ping, I know that IPv4 is installed and bound to the local NIC card. I could then, if I were having communication difficulties with this machine, I could start by checking, is IPv4 there and is it bound to the NIC? This tells me that it is. Okay. Now I could ping the actual IP address to determine, is that IP assigned and bound to the local NIC? Can it talk to itself? Yep, it can. Now I can ping the gateway to see if we can get off this machine. Can we get to the router? There, we can get to the router. And then maybe what I want to try is something on the other side of the router. And just off the top of my head, I know that this address is for the Google DNS servers. And so we could try to ping them out on the public internet. So I've got full communication with this machine. Dig it? You can ping by name as well. And so I could ping google.com, for example. And then I'll get back the IP addresses associated with that. Now, you can also trace the route. You can do a trace route to determine the path, the hops to another machine. So, for example, on my network here, I have a machine called K9 DC? Yes. And 1 millisecond, round trip. There's the IP address for K9 DC. I know it's up and running. You could do this out on the public internet, but a lot of times those requests time out because the routers between me and thee are configured not to respond to these requests, right? The folks that own those routers don't necessarily want this information shared with just anybody. Netstat will tell me what open connections this machine has to other connections. So I can see that it's talking to K9DC, which is good, right? I want to know that my domain controllers are talking to each other. It's talking to a client machine. And then we see that : 1, that's the IPv6 loopback. And so it's talking to itself as well. Finally, for testing DNS, there's NS lookup. And I can enter NS lookup, and I see that I'm using my local server as my DNS server. I could look for particular types of records. For example, I could set type equal SOA, the start of authority record, then specify the domain, which in our example is earthfarm.com. And then I get back the details on the DNS for Earthfarm, the start of authority record for Earthfarm. And I can quit NSLOOKUP and return to the command prompt with the quit command. This is a look at the command line tools used for networking. In this demonstration, we want to take a look at some of the command line tools that are available for managing the system processes and the disk. Now, the tricky bit with this demo, guys, is if I execute any of these commands, the demo is going to be over. So let's take a look at a couple of things here. The first thing is the disk part utility. Now, disk part is the disk partition command line tool. And so if I ask for some help on that, I see that there's really only one switch, and that's the script switch. And disk part wants me to call a script. And here's an example of what a disk part script might look like. And this is a script that I use to create a Windows recovery environment partition into which I load a custom set of tools that are used in the event that I have to do a system recovery or restore. And so the first line of the script is to specify which disk. Now, when we're talking about physical disks, physical devices always start counting at 0. Logical devices start counting at 1. So a logical partition on a drive would be partition 1. Then 2, 3, etc. While a physical disk, the first installed disk is always disk 0. And so I select disk 0 and I tell it to clean. Now, can you guess what clean means? Clean means to wipe all data from the drive. then convert it to a GUID partition table disk, create a primary partition, and I specify the size at 800 megs because that's how much room I need for my custom tool set. I do a quick format. The file system is NTFS. I see that I call the format command quick file system NTFS, and I give it a label, Windows Recovery Environment, and I assign a letter to it, the letter R for recovery, right? So simple script that I can use with the disk part utility. Now, the format command, which you saw included in the disk part utility, will format the drive. Now, I can format either the full physical drive or I can format a partition on that drive, a logical partition on that drive. And I can call things like the Q switch for a quick format. If I'm doing NTFS as the file system, and of course here I call file system FS, and then specify the file system type, FAT32, exFAT, NTFS, UDF, or the new resilient file system from Microsoft. And I can assign a label to it, etc., etc., etc. Again, I don't want to format this drive or we're going to be in trouble. From format, there's the shutdown command. And I can, from the command line, if I needed to shut down this machine, I could go ahead and shut it down. Again, that'll bring the demo to an halt, right? From shutdown, here's one, the system file checker. And the system file checker will scan the integrity of all protected system files and replace incorrect versions with the correct Microsoft versions, right? Task kill. Now, commonly, if I want to kill a process, I would call task kill and then give the process ID. And process IDs can be determined in a number of ways. Today, Task Manager reports process IDs. And so if I can't kill a task in Task Manager, or if it's not responsive in Task Manager, I might come into the command prompt with administrative credentials and try to kill it in here. Check disk is the one that we can run here. And that is the last of the ones in this demo that I have to cover. And so I'll go ahead and I'll run check disk. And check disk will check the file system. It'll look for bad sectors on the disk. It'll check file linkages, looking for broken files. It'll check the integrity of the file system structure. And now we can see the first thing here is that it tells us what the file system is, NTFS. Then stage one is to examine the basic file system structure. Stage two, examining file name linkage, looking for broken links, looking for files that are missing some of the data that's associated with them, or that might be able to be repaired using the check disk utility. Now, in our example here, I did not call the F parameter. So check disk is running in read-only mode. It won't make any changes. It's just going to take a look and report back to us what it finds. And stage two completes. And we see 0 unindexed files. So everything has been indexed. 0 unindexed files were recovered to lost and found. So there were no files that needed to be recovered. And then finally, stage 3 is running, examining the security descriptors, validating the integrity of the files on the disk. And here we get a final report, 0. This is what I'm really interested in with this. 0 kilobytes in bad sectors. So the disk is in good shape. And this is a look at some of the command line utilities for disk management in Windows. In this demonstration, we want to take a look at using the command line tools for group policy management and application. Now, if you're not familiar with group policy, to put it in a nutshell, group policy is a collection of user settings and computer settings. So there's 2 pieces to this. The computer settings are applied when the machine starts up. It contacts a domain controller and processes its group policy. Then when you log in, your authentication triggers the application of your profile settings. And these are commonly set by the administrator. Now, and then they're applied to everybody, right? Or to a subset of users. Now, I can do a GP result with the question mark, right, to get some help on this. And what I see is that I can do things like I can model this for a particular user. I can specify the remote domain controller to connect to if there's a particular domain controller I need to use. If I'm modeling it for a particular user, I'm going to need that user's password. I can limit the scope of this. I can generate a file either in XML or HTML. I can overwrite existing files if they exist. I can display summary data, which is what I'm going to do in just a second here. And then these, the verbose and super verbose, we tend not to use these. They just generate so much information. If you were doing real deep troubleshooting for a policy application, you might use these. But otherwise, I would avoid them, frankly. And so I'm going to go ahead and I'm going to call a GP result with the R switch so that I get a nice little summary report that's easy to see and easy to understand. And what I see here is the machine that I'm on, SRV01, its configuration, right? Whether or not it's detected a slow link, which will change. You can edit group policy so that it doesn't apply all of its settings if a slow link is detected, right? It can be big. There can be lots of data to come down. Now, the applied group policy objects, there's only one, the test GP results. I wanted this to be as simple and clear as we could get it. The local group policy is not applied at all because at the domain level, I have specified do not process local group policy. I don't want that interfering with my domain-based group policy objects. And then down here are all the groups that I'm a member of. Now, this test GP results policy, it's only got one setting, and it's a very simple setting. If I launch Internet Explorer, I will see, and I do that just by hitting the Internet Explorer icon down there on the taskbar. I will see that I come up, my home page here is Bing. Now, maybe I'd like to change that. Well, if I look in the Internet Options choice from the settings icon in the right-hand bar there, I see Internet Options. And I look, and this option is grayed out. And it's grayed out because the administrator has said you can't change that. We've agreed that this will be our home page for all company machines, and that's what it's going to be. Now, as you can imagine, you might get a lot of pushback on that. So what happens if I've received pushback on this, and I'm going to change the group policy setting? I'm switching consoles now to the domain controller. And on the domain controller, I have open the Group Policy Management Console. And if I look, the test GP results group policy object is associated with the IT users OU. So the account, my account, MJ Murphy, is a member of IT users. That's where my account lives. So these settings should apply to me. And I can see on the settings tab of this group policy object, under user configuration, administrative templates, Windows components, Internet Explorer, disable changing homepage settings. That setting is enabled. Well, I'm going to edit this policy. And again, that's a user setting, policy, administrative templates, Internet Explorer. Windows components, sorry. Windows components, Internet Explorer. And I can easily sort these alphabetically by clicking the settings choice at the top. And there's a choice right here to disable changing homepage settings. I'm going to disable this policy setting, which should mean that the user can now change their homepage. To test this, we'll return to the machine where I was logged in, and I'm going to call the GP update choice. And I'm going to call the force switch. Now, I don't actually have to, but I need to introduce that to you. Whoops. You got to spell it right when you're in the command line. There really are points off for spelling. GP update. Now, the force switch actually reprocesses all of group policy. This is great to know if you deal with remote clients who sometimes don't connect regularly to the domain and lose their security association, their trust relationship to the domain. When you reconnect those clients to the domain, you want to force them to reprocess all of group policy. Now, you'll notice here, I'm told that the updating computer policy update has completed successfully. User policy update has completed successfully. That looks good to me. If we do that GP result again with the R switch, again, test GP results was applied. I can see that here under applied group policy objects. Now let's go ahead and launch Internet Explorer and see if the change has taken effect. And now, wait a minute, I didn't open Bing. I opened my old home page, Google. That's what I want to see. That's exactly what I want to see. So this is a look at GP results and GP update. In this demonstration, we want to take a look at using the Windows Deployment and Imaging Services utility, the DISM tool. If I take a look in File Explorer, here on Drive E, I have a directory called WIMS. And in here I have some custom Windows image files that I've created for deploying Windows 2016, Windows 10, etc. And if I look, I can see that there's a boot.wim in here and an install.wim. And these are the default Windows image files that are to be found in the sources directory of any Windows installation media since Windows Vista. Now, those WIM files are the way that we deploy Windows today, right? We take a Windows image from the sources directory, we load it onto a machine, customize it, and then capture that image for deployment, commonly. And the tool that we can use to service these images when they're offline like this, say to keep an image updated with the latest updates from Microsoft Update, for example, is the deployment and imaging services tool. So here in the command prompt, DISM is a command line tool. I've set the directory to where the WIM files are found. So I'm in WIMs. Now, if I run just the DISM command, you can see what we get here. We get all the switches that are available to me. And in the time that we have available for this demonstration, I want to take a look at mounting an image, and so that I can service that image, right? I can add files to it, remove files from it, etc. You can see there are lots of commands in here if I wanted to delete an existing image, if I wanted to get a list of the files and folders in a specific image. For our purposes, let's go ahead and start by mounting an image. And so I'll begin by getting image info. I'll run dism get image info for the image file install.wim. And I need only specify the file name because I've set the working directory to the directory where the file is found. And I get all this information about that. And what I'm particularly interested in is the index number. I'm going to need the index number to call the specific installation image, because of course I can do a server core install from these image files. I can do a server with GUI, that's index 2, etc. So I'm going to call dism mount WIM file, and then I'm going to specify the full path to it there with the index number, and I'm going to set a mount directory. If I use the read-only switch, that will prevent any changes being made to this image while it's mounted. And I'm doing that because for the purposes of this demonstration, I just want to mount the image, show you what we get when it's mounted, and then unmount that image, ensuring that no changes have been made to my image. The great thing about this tool and this very simple process of mounting these image files is that once the image is mounted, we can actually come out of the command line and we can go into File Explorer and we can browse the file system as if this image were installed, right? We'll see all the directories in there. We'll see the program files directory. We'll see the Windows directory, users directory, everything that you would expect from an installed image. And that process goes pretty quickly. Operation completed successfully. Now let's take a look in File Explorer at what we get out of that. And here, if I open the mount directory, there it all is. Right? I can browse this tree. I can add files, delete files. Now, not in this example because I called the read-only switch. But if I hadn't, I'd be able to edit these and save those changes so that my installation image is up to date. For our purposes, I'm going to come back into the WIMs directory, minimize that, and jump back over to the command line. And now what we'll do is we'll unmount that image. And there's two switches that I want to be aware of, the discard and the commit switch. Commit would commit any changes I had made. Discard ensures that no changes are kept. And so I call dism whack unmount WIM, whack mount directory, and then specify the path to that mount directory. And that mount directory is just a folder that I called mount that I keep on the drive. So anytime I want to mount an image, I know I just call E whack mount. And then, of course, the discard switch to ensure that any changes that were made are discarded. And we're closing that all down. And now that'll go very quickly to the end. Bang. And if we return to File Explorer for just a moment, and we were to open that mount directory, we can see that that directory is now empty. This is an introduction to the Deployment and Imaging Services tool, the DISM command line tool, for working with Windows images. So what we used to do was we used to install this thing called Xcopy, which was originally developed by IBM. In this demonstration, we want to examine the copy, Xcopy, and robocopy command lines for copying files. Now, here's the thing about this, guys. You can copy files just fine in the graphical user interface, right? I have File Explorer open here. I can grab a bunch of files, copy them, fine. The thing is, for repetitive tasks, if you have a bunch of, say, performance logs that you want to copy off this machine to a network location where they can be collated, and that happens every week, well, you're going to want to script that solution, right? And when Windows first premiered, we used the copy command for that, but the copy command was very limited. And so what we used to do was we used to install this thing called Xcopy, which was originally developed by IBM. Eventually, Xcopy was licensed and included with the Microsoft software, though. So it was built in. So before XP, you had to install it. After XP, it was right there for you. But Xcopy had its own limitations, and so Microsoft developed robocopy, which I think it was Mark Rusinovich's group Sys internals. That was bought by Microsoft that actually did the work on that. And so for anybody that's actually working in the business today, robocopy is where it's at, right? Either that or there's some of the options that are available to you in PowerShell for this sort of thing. Now, for those of us taking the A+ certification exam, my best advice to you guys is to actually go in and use the old copy command, get familiar with it, use the old Xcopy command, get familiar with it, enough at least to pass the test, right? Have some idea what the switches do and how they work. But where you want to spend your time in real life for all your real scripting needs today is with robocopy. So real quick, let's start with the old copy command. And so down here on the taskbar, I'm going to go ahead and launch a command prompt. And if I ask for help on the copy command, and to give you some sense of this thing, how old it is, look at, there's no space there, there's no dash, you got to do a whack copy or whack question mark to get the help. And I see that there's a couple basic switches there and a couple of parameters that I have to specify, the source, the destination. But this works best and easiest, I have found, if I do this. I'm going to change the directory to a folder that contains the files I want to copy. That's what you want to do. And so I'm going to change the directory to this folder that I've called to copy, right? And there's a bunch of files in there that I can, for example purposes. Now, if I want to copy from this folder to a folder I call to copy, or I'm sorry, that I call copied, right? I can call the copy command and then specify the destination. And let's say I want to copy all the text files that are in there. So I can use a wildcard, and wildcards you can use for all these, wildcard txt. So copy all text files from the current directory to the folder called copied. Now, there are existing files there. Do I want to overwrite them all? Yes, I'll say A for all. There's only one file. It was copied. It overwrote the old one. Now, if I didn't want it to overwrite it, I could say no, and I could specify parameters to give it new names, etc. If I wanted to copy all the files in there, rather than specify the txt, I could again use a wildcard here. Copy all, right? Do I want to overwrite them all? A for all. Yes, there, all 14 files are copied over. And that gives you a sense of the copy command. And really, everything else builds on that understanding. And so if we were to look at, let's say, xcopy, right, which, again, is not going to be preferred in daily use today. Instead, I'm going to prefer to go right to robocopy. And the reason for that is because of the switches. Now, you look here and you can see there's a wildly larger number of options than I had with copy, which is why we acquired the xcopy command in the first place, right? Prompts you before creating each destination file. If the destination does not exist, then it assumes the destination must be a directory. Do you want to create it? Do you want to overwrite read-only files, copies hidden in system files, which the copy command could not do? And so that gives you some idea of how xcopy was built on top of copy, and then robocopy is just an extension of all of that, right? And look at how the help goes on and on and on. And I mean, not only does it go on and on and on, but it gives me examples, which I don't have with the other, right? Just take a look here. So all of these are intended to let you script repetitive file copying tasks. And today, the one you want to spend your time on is robocopy. Now, if you're taking the A+ certification exam, one of the things they always hammered on was the distinction between xcopy and copy, that you had to install the xcopy command. It wasn't native to Windows. And if you needed to copy hidden or system files and folders, you would need xcopy because copy did not do that. So those are some test suggestions and test nuggets for those of you getting ready for the A+ certification exam. In this demonstration, we want to introduce the net use command, which is a command line tool for mapping network drives. Now, a lot of us are familiar with the File Explorer that I have open here. And if I look in the left-hand navigation pane, I see this PC. And I can see that this PC has a C drive, that's the hard drive where the operating system is installed. And then there's a DVD drive, the D drive. Now, everybody knows the A drive was the floppy drive, right? Well, what about B? What was the B drive? Well, there was a time before we had hard drives that you'd load your operating system with a floppy disk in A, and then if you wanted to run Lotus 123 or WordStar, you'd put that disk in A, and you'd put a blank disk in B, and you'd save your work to B, right? You'd run your applications from A, save your work to B. So A, B, and C are verboten for mapping network drives. We do not use those letters. So that leaves another, 23 letters of the alphabet to use, and then mount points if you run out of letters. And probably most of the folks listening to this demonstration know that you can right-click on the PC, and there's a choice to map a network drive. I want to point to some share out on the network and make that data repository available on this machine. And in the GUI, we're prompted for the drive letter that we want to assign to this map drive, the UNC path name, which always looks like this, right? Whack, whack, computer name, and then share name, which in our example is share. Do I reconnect at login? Well, that's what we call a persistent connection. And do I connect using the current credentials, or do I connect using different credentials? And I could specify those credentials here. If I choose connect using different connection credentials, when I finish, it will prompt me for that credential set. Now, in our example here, we don't actually want to create the map drive using the GUI, although I think looking at it here is valuable because we see all the options that we're going to call from the command line. So I'm going to minimize the File Explorer window and come into the command prompt. And in the command prompt, I'll go ahead and I'll call the command. This is just like right-clicking on the PC and saying map a network drive. I'm going to say net use. Now, the GUI suggested that we use Z, and that's a good practice to start at the lower end of the alphabet so you don't run into conflicts with those first few letters. And again, the path, the UNC, the Universal Naming Convention name, is the computer name with the share name, which in our example is simply share. Now, if I want to reconnect at login, then what I want is for a persistent connection. And that's got a binary value, either yes or no. And so I do a colon yes for that. And then if I'm going to reconnect every time, am I using the current credentials, or am I using another set of credentials? If I were using another set of credentials, then I would have to specify the user parameter with a password, or if I'm using my own credentials, as we are here, I can do a save cred, and it'll save my current logged on credentials in order to reconnect. And so what we have here then is net use, the drive letter specification, the path to the share, whether the connection reconnects at login, it's persistent, and are we using the current credentials and saving them, or would you like to specify a user? And if I go ahead and hit enter, it tells me the command completed successfully. And so down here on the taskbar, we can validate that if we jump back to File Explorer and we refresh this view. There is the share on TARDIS 2, and I see that I have access to everything that's in there. Now, it's worth pointing out that in addition to net use to create a mapped network drive, you can use it to delete a mapped network drive. Just so, net use Z delete. Deleted successfully. If we jump back over to the File Explorer window and take a look at this PC, we can see that that drive mapping has been removed. This is a look at net use for mapping network drives from the command line.